Right now, somewhere on Earth, engineers are building a structure the size of a small town for one single purpose: to keep an artificial intelligence alive. And that structure has a problem so enormous that it could stop the entire AI revolution dead in its tracks. It is not a software bug, it is not a shortage of data, it is not even a lack of computing chips. It is something far more basic, far more brutal, and far harder to fix. AI is running out of power. Literally. And the thing that just cracked this problem wide open is not a new model, not a new GPU, not a smarter algorithm. It is quantum computing. And in 2026, it just did something nobody expected this soon. To understand why this matters, you first need to understand the wall that artificial intelligence is about to slam into at full speed. Every time you talk to an AI, every image it generates, every answer it gives you, it burns electricity. A lot of it, not a phone charger amount, a power plant amount. Training a single large AI model can consume as much electricity as several American homes use in their entire lifetimes. And training is the easy part. The hard part is what engineers call inference, running that model after it's built. That happens billions of times a day, every second, around the clock, never stopping. So companies did the only thing they could. They started building data centers, bigger and bigger and bigger. The numbers behind this are almost impossible to believe. The world is now pouring hundreds of billions of dollars a year into AI data center infrastructure. Microsoft, Meta, Google, Amazon, every major tech giant on the planet is racing to build the most powerful computing facilities money can buy, each one committing tens of billions of dollars in a single year. And here's the part nobody talks about loudly enough: that power doesn't come from nowhere. The International Energy Agency now projects that global data center electricity use is heading past 1,000 terawatt hours. To put that in human terms, that is roughly the entire annual electricity consumption of a major industrialized nation, consumed just by data centers. In some countries, data centers already eat a fifth of the entire national power supply. In the United States, projects that locked in land and funding years ago are now sitting frozen, waiting years just to connect to the grid. Some regions have started canceling data center projects outright. One U.S. state passed a moratorium on building large ones at all. The AI industry built itself a monster, and now that monster is eating the power grid alive. If that doesn't unsettle you, hit subscribe right now, because what comes next is the part that changes everything. Here is the uncomfortable truth the industry has quietly accepted. The bottleneck for artificial intelligence is no longer intelligence, it's energy. You can design a smarter model, you can buy more chips, but you cannot magically conjure more electricity out of a grid that is already maxed out. Money can't fix it fast enough. Engineering can't fix it fast enough. Physics itself is the obstacle, and the reason traces all the way down to how today's computers actually think. Every classical computer, and even the most advanced AI supercomputer on Earth, works with bits, and every bit is either a 0 or a 1, one at a time. Simple, reliable, and catastrophically power-hungry at the scale modern AI demands. When you ask an AI to find the best answer among billions of possibilities, a classical machine has to grind through those possibilities more or less one path at a time, brute forcing its way to a solution while drawing staggering amounts of energy the entire way. The whole trillion-dollar data center empire exists for one reason. Classical computing is the only tool we've ever had to do this job. But quantum computing does not play by those rules, and that single fact is what just broke the problem open. Quantum computers don't use bits, they use qubits. And a qubit can be a 0, a 1, or, through a property called superposition, both at the same time. Now layer on a second piece of quantum strangeness: entanglement. Two qubits can become linked so tightly that the state of one instantly reflects the state of the other. Together, these two properties let a quantum machine explore an almost incomprehensible number of possibilities at once instead of marching through them one by one. And this is exactly the kind of work that's draining the world's power grids. Because here's what AI data centers actually spend most of their energy on. It's not magic, it's optimization. Finding the best solution among billions of options. Training a neural network is an optimization problem. Recommendations, fraud detection, logistics, drug discovery, all optimization. And optimization is the single category of problem where quantum computing has its most dramatic advantage. In 2026, the biggest names in the field crossed lines that were considered theoretical just 2 years earlier. Google demonstrated a verifiable quantum advantage with its Willow chip, reporting that a specific algorithm ran on the order of thousands of times faster than the best classical supercomputers could manage. IBM pushed its quantum processors past the 1,000 qubit mark. Microsoft made real progress on a chip architecture designed to resist errors at the hardware level. To capture how big the gap can be, analysts have described quantum systems approaching problems that would take a classical supercomputer thousands of years and solving the right kind of them in minutes. Read that again. Thousands of years versus minutes. That is not an upgrade. That is not an improvement. That is a completely different category of machine. And if that just rearranged something in your brain, go ahead and like this video because the implications are about to reshape every AI investment on the planet. Now connect the two stories. AI's biggest problem is energy. Quantum's biggest strength is doing the most energy-hungry work using a fraction of the power. A quantum processor itself sips relatively little energy during the actual computation. The expensive part is keeping its qubits colder than outer space. But one quantum processor running millions of calculations at once can replace the work of hundreds of thousands of classical chips grinding away sequentially. The energy equation flips, the infrastructure equation flips, and the $1 trillion sitting inside today's classical data centers suddenly starts to look very, very different. Here's the critical thing. Quantum does not have to fully replace classical computing for this to matter. The disruption begins the moment a credible timeline appears, and many experts now place practical, fault-tolerant quantum systems somewhere between 2028 and 2030. So ask the question every CFO in tech is now whispering, why spend $5 billion on a classical AI data center in 2026 if credible quantum hardware arrives by 2030? The investment math bends, the capital starts to move, and the companies that already sank billions into classical infrastructure face a deeply uncomfortable question about what those assets will be worth. Even the loudest quantum skeptics in the industry, the ones who said useful quantum machines were decades away, have been forced to walk their timelines back as breakthrough after breakthrough landed. When the skeptics start hedging, that tells you which way the wind is blowing. There's a second edge to this story, and it has nothing to do with efficiency. As quantum computers grow stronger, they threaten the encryption that protects every piece of data inside every data center on Earth. Bank transactions, government secrets, your personal information. All of it is locked by math problems that are practically impossible for classical computers to crack, and that quantum machines may one day solve with relative ease. The security world has a name for that moment. They call it Q-Day, and enterprises are now being told that quantum-safe protocols won't be optional much longer. So the data centers being built today may need to be rebuilt or deeply retrofitted just to survive in a post-quantum world. Another layer of cost, another reason the current model is running on borrowed time. Now, let me be straight with you because most channels won't be. Quantum did not literally kill the AI data center. Not today. Classical computers aren't vanishing next Tuesday, and a lot of the boldest quantum numbers come from very specific benchmarks, not from some all-powerful machine that does everything faster. What's actually coming is a hybrid world, quantum processors handling the brutal optimization and simulation problems, classical systems handling storage, everyday inference, and the vast majority of normal work. Data center operators are already carving out dedicated quantum zones inside their facilities, placing quantum coprocessors right next to classical hardware. The data center isn't dying, its center of gravity is shifting, and that shift is the whole story. And here's the part that hits closer to home than most tech coverage ever admits. The AI boom isn't being paid for only by the tech giants. Across the U.S., utilities are planning to spend on a scale where ordinary households end up absorbing a huge share of the cost through higher electricity bills, rate hikes, and grid upgrades they never asked for. Electricity prices for regular families have already climbed sharply in recent years, and analysts have warned that data center demand could keep pushing them up. Ordinary people are quietly subsidizing a technological revolution most of them don't even know is happening, without ever getting a stock option or a thank you note. So when quantum computing finally delivers the same AI power at a fraction of the energy cost, that won't just be a win for Silicon Valley, it'll be relief for the power grid, relief for electricity prices, and relief for every household that's been footing the bill in silence. That's the human story behind the technology story, and it matters. So here's the bottom line. AI's biggest problem was never intelligence, it was power. And for the first time, something has cracked that problem wide open, not by making AI smarter, but by reinventing the machine underneath it. The question is no longer if quantum will reshape AI's infrastructure. It's how fast. And what we're watching right now in real time in 2026 may be the opening act of the most consequential technology shift since the internet itself. The people who see it coming, while everyone else argues about electricity bills and gigawatts, will be the ones holding the future in their hands. Make sure you're one of them. If this video helped you see even a piece of that future more clearly, hit like and subscribe because this story is only going to get bigger from here.